Welcome to first session, that is microcontroller, subject code 18EC 46. So now today we have the first we will see the first session of module 1. The module 1 is 8051 microcontroller. The subject is microcontroller and the first module 8051 microcontroller module 1 and session 1. So now the contents of this session will follow like this. So the first one, we will see what do you mean by microcontroller and what do you mean by microprocessor, and then we will see the difference of both of that. We will see the difference of MUSI means that is microcontroller and MP means the microprocessor, and after that we will see what do you mean by embedded systems and next embedded microcontrollers. So these are the four topics. So what we will discuss in this session. So let us move on to the first topic, the microcontroller. So the basically, what is a microcontroller? So microcontroller is highly integrated chip that contains the CPU, RAM, special and general purpose register arrays, on chip flash, and memory for the means on chip the RAM and flash for memory storage means program storage, timer and interrupt control, and dedicated IO ports. So now here, so the microcontroller, so what we are seeing, the figure what we are seeing here, okay, so this is IC. So already in the third semester you had the digital system design. So in that we know that in the lab also we have seen the different ICs. So IC means that is integrated circuit, and the chip also we call as a IC now. So now both are same. So you can see here the IC name, what it is displayed on the IC here, that is 8051. So that is a number or a series 8051, so which is manufactured by the Intel company. Okay, so what is this basically? So the microcontroller is nothing but a chip. So what we are seeing here, this is a chip which contains inside this IC, it has a CPU means the central processing unit, the RAM means the random access memory, that is to store the temporary values during the running, and special and general purpose register. So register is also the small array, small memory we can call as the small memory register arrays. Okay, and on chip flash memory. Two means basically the microcontroller, how it will work is we need to write a program. Okay, it can be assembly language or the C language, high level C language. Okay, so we need to write a program, the program, so which will be downloaded or fused into this IC, and whatever the logic we will write through the instructions of the 8051 microcontroller, so it will act like this. Okay, so whatever the program we will write, so that will be stored onto the ROM. So that's why the ROM is required. Okay, and CPU is a central processing unit. Okay, so this is a main part of the IC, so which will do according to the instructions. So what is the job of that? So each one will be executed by the CPU, and whatever the register, so temporary values, it will be stored here. Okay, so these all are means the memory, register, RAM, ROM and register. With this we have the timer, means the timer, so how much time the program should execute, when it should execute, all those things. And the interrupt control units means suppose if there are many functions happening at a time, so which one we need to start, so which one we need to give priority as a first, so that is which will be controlled by the interrupt control. And IO ports means whatever the system what we are saying. Okay, so we need to give the inputs and we need to get the outputs, so in between the system will be there. So for example, so this is for example input, and here will be the system, and after that here will be the outputs. Okay, so whatever system we call as the microcontroller, so whatever inputs we are giving, or it will take from the sensor, so that is through the IO ports. So whatever I and O we call as IO ports. Okay, so these all are consist within this single IC. Okay, so this we call as the microcontroller. Okay, so now the next, so we know that now the microcontroller is a chip, so which will do some specific function. Okay, so with the help of program, what we will write, and it has some peripherals we call as RAM, ROM, and timer, IO devices, and registers, all those things. Okay, all together it is one chip that we call as a microcontroller. The next one, so now the same microcontroller, so we can just define in the sense, so definition we have seen. Okay, the same thing in one more way. So it is basically the small computer on a chip. Okay, so which will do whatever the user will request. So all that will be done by the microcontroller. So that we call, that is a small it is act like the small computer on a chip, and we call as on chip. So on chip in the sense, within the chip we have RAM, ROM, IO ports, timer, serial controller. So whatever I have told in the previous slide, the same thing. So all these peripherals, it will be in the single IC. Okay, the example for that. So in the market we have the microcontrollers. From the Intel we have 8051. From Motorola company we have 6811. From Atmel it is 32. So like that, the Intel, Motorola, and Atmel are the we call as vendors or manufacturers which will develop these microcontroller ICs. Okay, so now this is like a chip what we have seen in the previous. Okay, so in a diagrammatic way, this shows what is a microcontroller, so which has CPU, RAM, ROM, IO port, timer, serial COM port, etc. Okay, so all this in a single chip, that's what it is mentioned here. Okay, so this is how means in the block diagram way how the microcontroller will looks like. Okay, the next one, microprocessor. Okay, so microprocessor, here it is a we call as so which consist, so microprocessor which consists of the CPU. Okay, which consists of CPU, that is central processing unit. Okay, so this is IC. Okay, this is means microprocessor, it consists of CPU, which is simple, means this is one IC. Okay, IC with external, means the CPU inside, again the architecture we will see in detail later. Okay, so that CPU consists of ALU, that we call as arithmetic logic unit, and some temporary registers and data bus, address bus, all those things it will be there. So that inner details of the CPU we will see later. Okay, so now what is, so microcontroller we have seen. So microcontroller, in that microcontroller in single chip, all these things inside the one chip only. But if you come to the microprocessor, the CPU itself is one chip, and this RAM is external chip, ROM is external, and IO port is external, timer external, and serial port is external. So all these are different chips. Okay, so all these are the different chips, means the microcontroller, the main CPU, and it is connected with the different chips here. Okay, so this together overall means this collection of these CPU and these all chips we call as a, together we are calling as the microprocessor. Okay, so microprocessor based system. So this is a microprocessor which don't have on chip these peripherals. Okay, it will not be within the chip, this is separate chip and this is separate, these are separate chip. So this is microcontroller based system. Okay, so this is a microprocessor. So this is what the difference between okay, we will see the different points in the next slide, but this is the architecture difference between the microcontroller and the microprocessor. And the different vendors from the Intel, we have the different microprocessor chips, that is 8086, 80286, 480486. Okay, and Pentium. Okay, this is also old series only, but it started with 886. Okay, and Motorola is 68000 series processor. Okay, so this is regarding we knew what is microcontroller and what is microprocessor. Okay, now the difference. Okay, so what is the difference? This is the main point. Okay, the difference between the microprocessor and microcontroller. So this session is microprocessor and this section is the microcontroller. Okay, so let us take a first point, and here the microprocessor contains ALU, as I told previous, ALU, general purpose registers, stack pointer, program counter, clock timing circuit, interrupt circuit. Means the microprocessor contains these all things: ALU, general purpose register, stack pointer, program counter, timing, interrupt. These all are within the single IC. Okay, program counter, stack pointer, these are we call as a temporary registers. Okay, inner details of this, what is stack and program counter, these all things we'll see later. So the IC consists of these things. Okay, whereas if you come to the microcontroller contains microprocessor, that is CPU. Okay, that is CPU, and in addition to that, in single IC only. Okay, if you take the single IC, the CPU block plus these all blocks within a single IC. Okay, so it consists of microprocessor. With that, in addition to that, ROM, RAM, IO devices, timers and counters, all within a single chip. Okay, so that is a major difference between the microprocessor and microcontroller. And the next one, it has many instructions to move data between memory and CPU. Okay, so as I told, in microprocessor, CPU is different, memory IC is different. Okay, there are many instructions so used which will be used to send the data between the CPU and the memory in case of microprocessor. So if you come to microcontroller, it is very few instructions. Okay, so few instructions because it is already within the IC only. Okay, so much instructions are not required, so less instructions we'll use. Then few bit handling and many bit handling. Okay, so these all things, each instructions we will see in the subsequent modules. So here at this point, so bit handling means, suppose we have some bits. Okay, suppose one register is nothing but collection of bits. Suppose we have some bits like this on register, so we can operate particular bit we can set. Okay, for example 0 1 2 3, if you take a position, I want to set third bit. Okay, particular third bit I want to set through the programming. So that kind of operation, it is a few bit instructions in microprocessor and many instructions in the microcontroller. Okay, similarly the next, less pin numbers are multifunctional and more pins are multifunction. So multifunctional in the sense, the same pin. So if you take the IC here, the particular pin, for example one pin, it can be used for different purposes. It can be used for the different purposes. So that we call as the multifunctional pin. Okay, so that is, in microprocessor we have less number of multifunctional pins, and in microcontroller we have more. Okay, similarly single memory map for data and code. Okay, so single memory map for data and code. So we can, at present we can think as the single memory for instruction and data in microprocessor. So here it is, instruction memory is different and data memory is different. Okay, so instruction and data in the single memory, and instruction memory is separate and data memory is separate. Okay, so that's what the meaning of the fourth point here. And the next one, access time for memory and IO devices are more, and access time for built-in memory and IO is less. Okay, means as we know, the CPU, if you want to interact with memory or IO device, okay, these are all external. Okay, so CPU IC is separate, memory IC is separate, IO IC is separate, these are external, so it will take more time. So if you take the microcontroller, CPU will be inside and memory will be inside, IO port will be inside. Okay, so all these within the IC itself, so it will take very less time. So this is what the fifth point. And as the same thing once again, the microprocessor based system requires additional hardware as it don't have built-in, so it is doesn't need, means if in case of specific application we need some of the external hardware devices. So more flexible in the design point of view and less flexible, means, so more flexible, why it is, because everything is outside, means all the ICs and IO ports and everything we are taking from the outside, so it is a design flexible. So whereas in microcontroller all are built in, so very complex huge complex designs we can't do with the microcontroller. And the next one, last, large number of instructions with flexible addressing mode, same thing. and limited number of instructions with few addressing modes. Okay, so addressing modes are the again it is a different concept. So addressing modes are the ways in which we can communicate with the processor. Okay, so in microprocessor we have large instructions, and microcontroller we have less instructions. So these are the different the points, the differences between the microprocessor and microcontroller. So basically we need to understand these things. Okay, the next one, embedded systems. So what is an embedded system? So embedded system is an electronic, or we can call as electromechanical system which is designed to perform specific function. Okay, so it is electronic or electromechanical system which is designed to perform the specific function, and is combination of the both hardware and software. Okay, that software we can call as a firmware. So in the technically we call as the firmware, so in general we can call as software. So the embedded system is a unit or a device so which consists of hardware and software, and it will do the specific function, so that we call as embedded system. Okay, so every embedded system is unique, and the hardware as well as firmware is highly specialized to particular application. Okay, so you'll see that which are the particular applications and all those things. So now what is embedded? It consists of hardware and software, and it will do the specific function. Okay, so now what is the purpose? Okay, so where it will be used, and what is the purpose of embedded systems? So basically the purpose of embedded system is to data collection. Okay, these are the purposes: data collection or storage or representation. Okay, means if you have any the satellite data, for example, if I want to collect the satellite data, so that I want to store it in some device, so that storing, okay, the storing operation will be done by the embedded system. Okay, capturing and storing, the two things there. Then communication, suppose I want to send one data from one place to other place. Okay, so that we can call as data communication. And digital signal processing. Okay, so digital signal processing means so whatever with related to voice related thing. Okay, voice, whatever what I am talking is maybe what is that, storing of that, here it means storing of that, processing of that, again storing and replay of that. Okay, so all those related to the voice related. Okay, so voice related thing, okay, so or image voice, whatever the signal processing. Okay, so that we call as the data signal processing. So that is there also the embedded systems are. So each one I am giving as example after this slide. Okay, so now you can call as voice related, and transfer of information, and data storage, and monitoring. Okay, so monitoring means the health condition what we will monitor. Okay, so body condition, so that monitoring. And control, so once we do storage or monitoring, once we do all this monitoring, so how to control that, so that is control application also will be done by embedded system. And all specific user interface. Okay, application specific user interface, so we call it GUI. Okay, suppose if you want to do ourselves as give the inputs and check all those things. Okay, we can call as all these whatever this oximeters and all those things. Okay, so oximeters, so which we will put on the finger, and by pressing the button it will give the details of the pulse rate and all those things. Okay, now it is highly needed. So these all things, oximeters and thermometers, all those things we call as embedded systems. Okay, so these are the technical things. Okay, what it will do: data collection, communication, processing, monitoring, control, and the user interface. Okay, so now let us see the example. So the one by one, as I told, so this is the storage. So if you want to store, okay, the capture or store or record, so that will be done by the camera. Okay, so this is data storage example. And the modem, so which will communicate or receive and transmit the information, so that is modem. And the signal processing, so as I said, so whatever I am talking, so we should listen properly. So hearing aid. Okay, so hearing aids we can call as the best one of the embedded systems. Okay, and monitoring, so as I told, the pulse rate and oxygen rate or whatever, all those things. Okay, heartbeat. Okay, so all this the monitoring health system, and this is control, so air, AC. Okay, so either based on the environment, based on the temperature, we need to increase or decrease the uh, temperature. Okay, cooling or heating, so that will be done by control. And last one is application specific user interface, that is mobile. All means basic need nowadays, so all of you have and using that. Okay, so these are the some of the examples with respect to what the purpose what we have given. So with this there are many embedded systems are there. Okay, so lot of embedded systems are there. You take washing machine. Okay, you take thermometers and whatever, what Bluetooth devices. Okay, so a lot of different devices, all these we call as a embedded systems. So in these embedded systems we are using microcontrollers. Okay, so in all these embedded systems we are using the microcontrollers. So now the major microcontroller is using the ARM machine, ARM microcontroller, advanced risk machine. Okay, so ARM is a company, advanced risk machine, so which will produce ARM 7 processor microcontrollers or processors, whatever it is. Okay, so these are the major microcontroller which will be using in the these all devices. Okay, so we knew what is embedded system and what are the examples of that. And this example, the small example, using the 8051. Okay, so what we are studying now, using 8051 IC, so we can develop the RF ID based, so radio frequency ID based access control using 8051. Okay, so if you see any hospitals or any colleges, okay, so at the door side, so if you if you show the ID card, so then the door will open. Okay, so that is the identification by using the ID card. So that is developed by using the 8051 microcontroller. Okay, so whatever the previous what we have seen, the high end complex embedded systems, that is with ARM controllers or some other high end the microcontrollers. Okay, so now so these are okay, so these are the examples of embedded systems what we will develop, what we have developed using the microcontrollers. Okay, so then the microcontrollers for embed, the same thing, the microcontrollers for embedded systems. So earlier, so before microcontroller, so as the microcontroller is having less flexibility, so they started with embedded system developing with a microprocessor itself. So 86 processor, x86 means for example 8086 and 286, 486, like that, by using those and also 68,000 from PowerPC, that is from Motorola. Okay, so from these two devices they have developed the embedded systems for high end. Okay, so later okay, a little bit, so what I had told just before this slide, RFID at colleges level and small scale industries, they have started with 8051 and 6811, and even the small students projects and all those things using PIC microcontrollers from microchip company, all those things. Okay, but nowadays as I told, so they are using the more in most places are microcontrollers. Okay, so these are microcontrollers will be using for the developing embedded systems. So now what is a major criteria how to choose microcontroller? Okay, so I want to design or I want to develop an embedded system, so how to choose the microcontroller? So there are 3 points here. The first one, okay, meeting the computing needs of the task at efficiency and cost effectively, means the whatever the design what we are doing. Okay, so if you want to choose microcontroller, it should do task efficiently in the sense we should do within the time and correctly, exactly and perfectly. Okay, so that is if we call as efficiently, and cost effective means the cost should be less. Okay, so that's what the sum of the parameters what I have mentioned here. The speed, okay, the microcontroller should have the high speed, and package means IO devices, the lot of IO devices it should support, and memory. Okay, so whatever the how much the big program or complexity program is there, that I must store in the memory. And power consumption, how much power it will be consumed. So there are many other the parameters will be there. So these are major parameters. By using these by seeing these parameters we need to choose the microcontroller. The next one, if you choose microcontroller, then what are the available tools, okay, such as compilers, assemblers, and debuggers. Okay, so compilers means once we write the program, it should be compiled, means it should be checked for errors and warnings. Okay, so that is we call as the compiler, so which will check the code. Okay, so whatever the microcontroller we are using, so that should have the software which should do the compilation of that particular program, and assembler, so which will convert a high level language to machine level, and debuggers. Okay, so before downloading into the hardware, okay, in the as a simulator I should check whether how my code is working and how much size it is taking. Okay, so all those we will see using the debuggers. Okay, so the whatever the microcontroller we will choose, it should have the compilers, assemblers, and the debuggers. And the last one, the wide availability and reliable sources of the microcontroller. So how much it is reliable? Okay, it is working fine, tools are there, how much it is reliable, and what are the availability? Suppose I need now 1000 microcontrollers, is it available? Okay, so all those things. So these are the three major criteria while choosing the microcontroller. Okay, so this is criteria for choosing microcontroller. And okay, so now these are the topics, four topics what we have discussed now. Means what is microcontroller, if you come to the contents, what is microcontroller and what is microprocessor. So both are chips only, but microcontroller have the CPU, have the microprocessor, and within that we have the peripherals. Okay, we have built-in peripherals in the microcontroller like RAM, ROM, all those things. And if you come to the microprocessor, the CPU, and we have external all these processor, means all these peripherals as ICs. And we have seen difference between both, and we have seen what is embedded system, and with examples of that, why it is required. Okay, and what is the application of 8051 microcontroller, and what are the microcontrollers we are using for embedded systems, and what is the criteria to choose the microcontroller. Okay, so these 4 points. In the next class we'll see the further sessions and the references. The textbook what I have mentioned in the syllabus, that is 8051 microcontroller and embedded systems, and that is Muhammad Ali Mazdi. Okay, and also one more book, Kenneth Ayla. And also I have searched in the internet and got some information and documents from the through the internet sources, so I'll acknowledge that, images and other things. Okay, so these are the references what I have referred. Thank you.